All right, now this is where it starts to get real fun. We're going to see that we can actually take the antiderivative or the indefinite integral of some pretty complicated functions using a technique that we learned last semester when we learned the chain rule. Essentially, this is reverse chain rule, but now we're going to call it reverse U substitution because that's kind of how we learned it last semester. So, all the same information here. Let's go to the next. When we discussed differentiation, one of the most important techniques we mastered was the chain rule. Remember, if there was a function inside a function, we had to take the derivative of the inside as well as the outside function. Now you learned the integration form of the chain rule called U substitution. Now we already did U substitution, so this is going to be easy. All you do is replace the function with U and du, then you integrate. So let me show you how it works. We have this 3x minus 1 to the 5th power. So we are going to make this our u. So let's write that over here. U equals 3x minus 1. And let's do the same thing that we did when we were taking the derivative. Let's go ahead and differentiate. You get du equals 3, but we have to kind of keep in mind the implicit form here. So this would be 3 dx. Okay. We replace this with the u, which is fine. So we have the integral of u to the 5th. But we don't want a dx there because now we're talking about in terms of u. So that's okay because we have a little solution or an equation here with a dx in it. So we could actually divide both sides by 3. And now we know that dx is actually equal to du over 3. So we could write this as du over 3. And really this 3 is just like multiplying by a third. And so that's just a coefficient. So you could write this as 1/3 times the integral u to the 5th du. All right. Well, now we can go ahead and do the same thing that we were doing before. We just take the antiderivative. It's pretty basic here. So this would be 1/3. I'm just going to leave it out front. And now u to the 5th becomes u to the 6th divided by the new exponent of 6. And of course, plus some constant c. Now, technically, you could put this constant inside here, right? And then you would distribute the 1/3. But if you think about it, you don't know what that constant is anyway. So it's still an unknown constant. It doesn't really matter whether it's inside or outside. So I would just leave it out and not make it more complicated. You don't need to make it some constant divided by 3 because some constant divided by 3 is just some other constant. So now, we're not fully done here, though, because we still have it in terms of u. So if we were to simplify this a little bit, it's really like u to the 6 over 3 times 6 is 18 plus c. And so we need to take what we have for u and just plug it back in. And remember, u is 3x minus 1, so this simply equals 3x minus 1 now to the 6th power over 18 plus c. Pretty straightforward. As you could see, using this technique that we learned last semester is going to make this a lot simpler. So maybe it was a little bit different for you or a little bit challenging for you then, but since this is something you've already learned, this process now is going to be quite a bit easier. So let's take a look at this next one. We can see how the U substitution is actually going to be really nice. So sometimes it takes a little bit of kind of guesswork to figure out what exactly is best to be your U. I usually like to make the most complicated thing my U, at least start there. So in this one, we can make the x squared plus 1 my U. So let's go over here. U equals x squared plus 1. And if I was to go ahead and take the derivative of that, I'd get du equals 2x dx. Okay, this is interesting because we see a 2x dx here, right? So sometimes this is going to be the case is that when you go and take the derivative, whatever you get for du will fit in nicely into the integral that's already there. So we can rewrite this whole thing as the integral of u squared, and instead of dx dx, that's simply equivalent to du. So this thing that was pretty complicated got really simple really quick. So do the antiderivative here now. This would simply be u cubed over 3 plus c. And now let's plug our u value back in. And this would be equal to x squared plus 1 to the 3rd power over 3 plus c. So this is where the u substitution can get just really powerful in making a complex problem very simple. Okay, As we look at this guy, the first thing that I would want you to recognize is that we probably don't want the square root symbol in here. We probably want to rewrite this as the integral of parentheses 2y minus 1 to the 1/2 dy. And so now we can go ahead and apply our u substitution. Remember, this guy inside here would be our u, so u equals 2y minus 1, and therefore du would equal 2, and then let's not forget the implicit form here of dy. Well, now we can rewrite this thing, right? So let's see. We have the integral, and instead of 2y minus 1, we're going to replace that with a u to the 1/2. But instead of dy, we need to solve for dy here. So we're going to divide by 2, divide by 2. And so dy is actually equal to du over 2. Again, this is just like a coefficient. So we can actually write this as 1/2 the integral of u to the 1/2 du. And now, again, we have a much simpler version. So let's do the antiderivative. This would be u to the 3/2. And instead of dividing by 3/2, I'm going to multiply by the reciprocal of 2/3. And then plus c. We can clean this up. These 2's cancel out. And it equals u to the 3/2 divided by 3 plus c. That's all there is to it. Let's go on to the next problem. Okay, this one's very similar, so I think I'm going to have you guys just try this one on your own. Again, just pause the video, give it a second, work it out, and then check back, see if you did it correctly. Okay, so we rewrite it as a exponent, and your u is obviously this thing in the middle, 5t minus 4. So if u equals 5t minus 4, your du would just equal 5 dt. We want to solve for dt, though, and so we get that dt is equal to du over 5. So we can rewrite this as the integral of u to the 1/2. Instead of dt, it's du over 5. That 5 can be replaced out here as a 1/5. So now we have a pretty simple problem here. So we have 1/5, and when we integrate 1/2, it becomes 3/2. And instead of dividing by 3/2, I multiplied by 2/3 plus some constant, and 3 times 5 turns into a 15 in the denominator. There we go. Let's go to the next page. Okay. This one's a little bit different, but really the process is exactly the same. It's just that now this u is here on the bottom. So u equals 4x minus 3, and again du would equal just simply 4 dx. Now we want to solve for dx, right? So we're going to divide by 4, divide by 4. So dx is equal to du over 4. So let's rewrite this. This is like saying the integral of, and this is really like u squared, but it's on the bottom, right? So we can just make this u to the negative 2, and instead of dx now, we can just say du over 4. Now, hopefully you saw what I did there. We just rewrote this u squared in the denominator as u to the negative 2. So let's also go ahead and rewrite the 1/4 out front, making this simply the integral of u to the negative 2 du. And we know how to take the antiderivative of this, so it's 1/4 times. This would be u to the negative 1 over negative 1. And, of course, plus some constant c. If we simplify this, it's simply negative 1 on top, because I can just move the negative on top, over, we just have a 4 and a u on the bottom, plus c. Now, again, we don't want this in terms of u, we want this in terms of x. So we're going to plug our u back in that we see up here at 4x minus 3. So this thing actually should equal negative 1 over 4 times 4x minus 3 plus c. So actually that is the answer we're looking for. Okay, one more problem. I believe you can do this one on your own. Again, just identify your u. Pretty simple to identify here. I'm pretty sure that's going to be your u. So you start off with u equaling x minus 1. I think you'll be able to work this one out on your own. Give it a shot, pause the video, and come back when you're ready to check your work. Alright, so this one's actually easier than it looks because the derivative of x minus 1 is just dx. So du and dx are exactly the same. So when you go to plug this in, you get u to the negative 2, because this is really in the denominator, so you can make a u to the negative 2. And instead of a dx, you can just replace it with the du, because they're equivalent. And now we can go ahead and do the antiderivative. It becomes u to the negative 1 over negative 1, and we've done this one enough times now that we can see it's just going to end up with negative 1 over u. replace the u and it's negative 1 over x minus 1 plus some c. All right, guys, pretty straightforward. See you guys on the next video.